You know that feeling when you're prompting an AI. You give it a few examples of a new pattern, and just like that, it gets it. It feels like pure magic. It seems to learn a new trick instantly, without any of that slow, painful retraining. Well, this incredible ability has been one of the biggest puzzles in AI, and now it looks like researchers are finally starting to crack the code.
Okay, to really get what's going on here, let's just think about it in human terms. It's super simple. Imagine you make up a new game with a friend, a rule they have never, ever heard before.
You test them just once, and bam, they get it, right? Their brain didn't have to go through some major rewiring process. They just integrated that new piece of info right there on the spot. And this is exactly what it looks like these big AI models are doing.
So that leads us to the big question, the real puzzle here. We know these models get pre-trained on these enormous data sets, but that training is supposed to be frozen, locked in. So how in the world are they learning new stuff right there in the chat window from just a couple of examples and a prompt?
This whole phenomenon actually has a name. It's called in-context learning, or ICL for short. And, for a while, this really kicked off a massive debate among researchers.
And this was the million-dollar question. Is the AI actually learning a new skill from scratch, like our friend learning the beep-boop game? Or is it all just smoke and mirrors? Was the model just using those examples as hints to find and pull up something it already knew from its training?
For a bit, that illusion theory made a lot of sense. Some of the first experiments showed that if you gave a model totally random, gibberish examples, it didn't always break, which kind of suggested it was just digging up old info. But then, as the models got bigger and way more powerful, the evidence started pointing the other way. These newer, massive models really did seem to be learning from the examples, even if they were random. And that pointed to a real, actual learning process happening on the fly.
So which one is it? An illusion, or is it actually learning? Well, a new paper puts forward this really cool theory that kind of solves the whole debate by saying, hey, what if it's a fascinating mix of both?
Okay, so this breakthrough idea is called an implicit weight update. Instead of picturing the model's brain as this static library of facts that never changes, this theory says, no, the model can actually make a temporary, super specific tweak to its own network. It's not full-on retraining, but it's not just grabbing an old file either. It's something new.
So here's the best way to wrap your head around it. The prompt you type in, it's basically like giving the AI a temporary sticky note. The AI looks at your examples, scribbles a quick instruction on that note, and slaps it onto the part of its brain it needs for your specific request. And when the conversation's over, the sticky note gets tossed. The core brain, totally unchanged.
So here's the breakdown of how it works, according to the paper. Researchers figured out that certain parts of the network, specifically the attention and MLP layers, they team up to create what the paper calls a contextual block. This block is what reads your examples, figures out the necessary adjustment, that's our sticky note, applies it internally, and then uses that temporarily modified brain to give you an answer.
Okay, so having a great theory is one thing, but you've got to prove it, right? And that's exactly what these researchers did.
They came up with this really clever experiment. Okay, so in test A, they do what we all do. They give a model a prompt with a bunch of examples, and then ask it a final question. But for test B, they did something wild. They actually took the math behind their sticky note theory, calculated the exact adjustment, and then manually applied that change to the model's brain. Then, and this is the cool part, they gave this newly tweaked model just the final question, no other examples at all.
So this creates the ultimate test. I mean, if this whole sticky note idea is correct, then both methods should spit out the very same answer. The model in the first test should be doing on its own implicitly what the researchers did by hand in the second test. So what happened? It worked. It totally worked. The paper says the results were in, and I'm quoting here, remarkable agreement. I mean, this was the smoking gun. It proved that this in-context learning thing isn't some fuzzy magic. It's a predictable, mathematical process that temporarily modifies the model's own internal wiring. Yeah, the results really do speak for themselves. If you look at this chart, which is based on the paper's findings, the prediction error, it's practically identical for both.
It's solid proof. Whether the model makes its own sticky note or a scientist slaps one on for it, you get the same result.
So this is a really important distinction to get. This whole sticky note update, it's fast, it's temporary, you can undo it. And that is a world away from traditional fine-tuning, which, is this slow, super intensive process that uses tons of data to permanently rewrite the model's brain. You could almost say in-context learning is like a kind of implicit, on-the-fly fine-tuning.
So what does all this really mean for how we think about AI?
All right, let's wrap this up. What are the big takeaways? First, we can be pretty sure now that in-context learning is a kind of implicit fine-tuning. The prompt you give it is basically a command to make a temporary change to its own weights. And it's not just one magical part of the model doing all the work. It's a team effort between different layers. And that's what gives these AIs their incredible flexibility.
And I think the researchers themselves said it perfectly. They said the real magic isn't just about one specific part, like self-attention. The real secret sauce is that these networks can take what you give them, your prompt, and turn it directly into a change in their own wiring.
And an insight like that, well, it really makes you rethink some basic assumptions about how these things work and what it even means to learn in the first place.
Which leaves us with one last really big question. For decades, when we talked about learning in AI, we meant that slow, grinding process of training. But if a model can update itself meaningfully in a split second from just a handful of examples, it completely blows up our old definition of learning, not just for machines, but maybe for us too.